January 2019, question 9a. Alright, it says the diagram below, not drawn to scale, shows a circle. The points P, Q, R, T, and V are on the circumference. QRS is a straight line. Angle PVR is equal to 75 degrees. And angle TRS is equal to 60 degrees. So all that is saying is what we can see for ourselves. We're asked to determine the value of each of the following angles, show detailed working where necessary, and give a reason to support your answer. So the first thing we're asked to find I. So this is question 9AI. And the first thing we're asked to find or asked to determine is the size of angle PTR. We're asked to determine the size of angle PTR, which is this angle here. Angle PTR is this angle here, and angle PTR is equal to 75 degrees. So I'm going to answer I. Angle PTR is equal to 75 degrees. And the reason here is that there are angles in the same segment. There are angles in the same segment. Alright, so angle PVR and angle PTR are angles in the same segment. Alright, they both start and end at the same point on the circumference, which is P and R, and the two angles are formed at the circumference in the same segment. So if I did this, the line PR is a chord, and a chord divides a circle into segments. So the angle PVR and PTR are angles that start and end at the same point on the circumference, and the angle itself is formed at the circumference in the same segment. So those two angles are equal, they're called angles in the same segment. Secondly, we're asked to determine the size of angle TPQ, angle TPQ, that is this angle here. Alright, now angle TPQ is equal to 60 degrees. Alright, so now first of all, TPQR is a cyclic quadrilateral. TPQR is a cyclic quadrilateral. QR is the exterior angle of a cyclic quadrilateral, and TPQ is the opposite interior angle. So angle TPQ is equal to 60 degrees. And the reason is this: the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. So the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. The third angle we're asked to find, the third and final angle we're asked to find, it says obtuse angle POR, where O is the center of the circle. Alright, so first of all, the center is not there, so let's put in the center here and call that point O. Now let's connect P to O and O to R. So there we're being asked to find angle POR. We're being asked to find angle POR, which would be that angle here. Alright, now So triple I would say that angle POR this angle here, I'm horrible at drawing that curve. So this angle here is 150 degrees. Alright, I'll tell you why in a second. Now, angle POR is equal to 75 times 2 is equal to 150 degrees. And the simple reason for that is that the angle at center is equal to 2 times the angle at circumference. The angle at the center is equal to 2 times the angle at the circumference. So we can look at it. We have angle POR, which is the angle at the center, and angle, let's say PVR, which is the angle at the circumference. Both angles start and end at the same point in the on the circumference. One angle is formed at the circumference, and the other angle is formed at the center. So PVR is an angle formed at the circumference, and POR is the angle formed at the center, and the angle at the center is equal to 2 times the angle at the circumference. So angle POR is equal to 150 degrees.